Hi guys, we're going to just finish up taking the notes on completing the square that we started on Thursday last week. And then you guys are going to have a chance to practice. But before you practice, I wanted to give you some more opportunities to see how to use the completing the square for a variety of different situations. So let's go ahead and open up our notes, and then we're just going to review what it is that we talked about last class. About completing the square, and then we're going to use it in a different context. Okay, when completing the square, remember the first thing you have to do is you have to find the C term when you are completing the square. That C term is found using b divided by 2 squared. When I do that, I add it to both sides of my equation. Remember, my equations are no longer equal to 0. It's equal to what would have been the C term if I were to put this in standard form. So you had to take it out of standard form before you did that. Once you added the C term, you were then given a perfect square trinomial that you could factor into a perfect square. Once you factored it into the perfect square, you were then easily able to find the square root of both sides to find what x is. We did that with a couple of different examples where there was no a value, but then we did it with an example where there was an a value. And by a value, I just mean a coefficient of that x squared. When we did it when there was an a value, we had to factor out that common factor, which was your a value, before you had ended up finding that perfect square trinomial, right? Okay. Today, what we're going to do is now we're going to move into how can I use completing the square to write something in vertex form. We're going to start again with an easy problem, and then we're going to get into something a little bit more complex, so make sure that you're paying attention when I am going over this second question. But first, we're going to start with something simple. If I want to put something in standard form, using this method is going to be the best way. The first thing that you are going to do is you are going to take your equation, y equals whatever squared, a squared plus b squared plus c, and turn it into an equation where you just have the a squared plus b squared on one side. So that means that I need to subtract the c term from both sides. Okay, so kind of like what we did to start, I'm using this strategy before, where I now just have our ax squared plus bx term on one side. Okay, once I do that, then I can go ahead and find my c term like I was doing before to add to this trinomial to make it a perfect square trinomial. And remember, the way that I do that is by taking the b term, dividing it by 2, and squaring it. So in this case, it's going to be negative 16, that's my b term, over 2 squared. So negative 16 divided by 2 is 8, and then 8 squared is 64. So what I'm going to do is I'm going to add 64 to both sides of my equation. Because what I do to one side, I always have to do to the other to make sure it's balanced. Once I do that, I can then simplify the right-hand side, but I can also turn this into a perfect square binomial. The way that I'm going to do it is by factoring. What two terms multiplied together also have a sum of negative 16, and that's negative 8. So that means that this is equivalent to 8x minus 8 squared. On the right-hand side, I have y. Now, instead of plus 64 minus 3, I can just combine the like terms and give me y plus 61. Now you might be able to see how we can easily use this to turn the equation into vertex form, and this is by subtracting the 61 from both sides, and now I have a vertex form quadratic. Okay. So just to back up, what we did is we made sure that we turned this into that ax squared plus bx form on one side by subtracting the 3 on both sides. We then added to the b over 2 squared to create a perfect square trinomial, and then we were able to factor it, which then makes it real easy to put it into vertex form. The second example here gets a little trickier, and the reason why it gets a little trickier is because I now have an a value. We're going to start this the same way we started the other one, but we're going to have to do something with that a value so that we can turn this into a perfect square trinomial. Okay? The first thing I'll do, again, is I'm going to add 2 to both sides, which gives me y plus 2 equals 3x squared minus 6x. Now this is where things get a little tricky. I have to factor out the common fact here to make sure that this x squared term does not have a coefficient. So we know that both of them are divisible by 3, so I can pull out the 3, which then gives me x squared minus 2x on the right-hand side of the equation. The left-hand side of the equation, we're going to leave it how it is. So now what I need to do is I need to turn this portion right here of my function into that perfect square. Now in order to do that, I'm going to do exactly like what I did up here. I'm going to do b divided by 2 squared. So in this case, it's going to be negative 2 divided by 2 squared, which equals 1. So that means that I'm going to have to add 1 to this part of the problem. Now, when I add 1, I want you to look at this. What I'm actually adding is not 1 to the equation. And the reason why is because that 1 is being multiplied by the 3 that we took out of the parentheses. We factored it out already. So what I'm actually adding to both sides is not 1, but whatever 3 times 1 is, and that is 3. So on this other side of the equation, instead of adding 1 like I did, I'm actually going to add 3. That right there is one of the common mistakes that people make when they try to convert one of these types of problems to vertex form. They would, some people would add 1 here because they say, oh, I added 1, why don't I add 1 to this side too? Just keep in mind, you're not really adding 1 to this side of the equation. You're adding 1 times 3. So be very, very careful when you approach a problem like that. Okay? Now that I've done that, I can do exactly like what I did before in the previous problem. I'm going to turn this into a perfect square, or it is a perfect square, so I'm going to have to factor it into its perfect square binomial, which is x minus 1 squared. We have the 3 in front, and then on the right-hand side I have y plus 5. The last thing I'm going to do is subtract 5 from both sides, and then I end up with an equation in vertex form. So be very, very careful with problems like this where you're factoring out that a term. You want to make sure that you're making both sides of the equation equivalent, and that's going to require you to do some multiplication. If you need to go back and pause my video, rewind the video, please feel free to do that. I just want to make sure that you don't forget to do that. All right, we're going to move on to question number 7, which is one of those triangle questions. I did one of these for the warm-up the other day, but I want to make sure you have one in your notes. So it says, find the value of x given that the base of a triangle, here's the base of my triangle, is x plus 4 inches, the height of the triangle is x inches, and the total area equals 8 inches squared. Oh, I guess we did this on the homework last week. So we're going to go ahead and do this again. Now, in order to find the area of a triangle, we know the formula is 1/2 base times height. So we're just going to go ahead and use what we know about the base and the height to put this into our triangle. So if I have 1/2, my base is x, my height is x plus 4, and I know the area is 8, this right here is my equation. We're going to simplify this equation. I'm going to multiply the x and the x plus 4 first. And actually, you know what, I'm going to do a little different one than the last time. I'm going to multiply out the fraction first. I'm going to multiply both sides by 2, and that way we don't have the fraction anymore. Just makes the problem look a little more simple. So when I multiply by 2, this cancels, and then on the right-hand side, I just get equals 16. So now this is pretty easy. All I have to do is multiply x and x plus 4. So this is x squared plus 4x equals 16. This right here, let's go ahead and make it a perfect square trinomial by doing b over 2 squared. So 4 divided by 2 squared is 4. And then that gives me x squared plus 4x plus 4 equals 16 plus 4. Don't forget, you have to add 4 to both sides. Now if I factor this is x plus 2 squared. So we have x plus 2 squared equals 20. Okay, now in order to solve this, I'm going to find the square root of both sides, which gives me x, here I'm going to come up here, x plus 2 equals the positive and negative, the square root of 20. Now remember, we have to solve this using 2 different equations since I've got the positive and I have the negative. So I am going to rewrite this. So I have x plus 2 equals square root of 20 and x plus 2 equals the square root of, or negative square root of 20. Okay, now for both of these, I'm going to subtract 2 from both sides, where I'm then going to end up with negative 2. Now I can rewrite this as plus and minus 20, just to make it a little easy on myself. So we've figured out the height, the value of x, given that the base was x plus 4 and the height was x, by finding, by completing the square. Okay, with the last problem, we're going to find the value of x if the area of the rectangle is 168 square units. All right, we do not need to use 1/2 base times height. We're just going to do length times width. Here it's a little more simple. So length times width is 6x times x minus 6. We're going to make that equal to 168. If I simplify, we get 6x squared minus 36x equals 168. And now we can go ahead and find the perfect, complete the square to find the value of x. Okay, remember, when I have a term, the first thing I need to do is pull out that a term so we can complete the square properly. And then I'll use my b value to find what c term I need to multiply both sides by. Oh, actually, before I do that, I should divide out by 6. So 168 divided by 6 is 28. So now we're going to complete the square. So our b term here is negative 6. We're going to divide by 2 and then and then square it. So negative 6 divided by 2 is negative 3. Squared is 9. So I'm going to add 9 to both sides of my equation. And then that's going to allow me to create a perfect square binomial, which is negative x minus 3 squared equals 28 plus 9 is 37. Again, I'm going to do what I did up here. I'm going to find the square root of both sides, which gives me x minus 3 equals positive and negative 30, the square root of 37. Last but not least, let's go ahead and add 3 to both sides, which gives me x equals 3 plus or minus the square root of 37. And 37 is prime, so we're going to leave it how it is. All right. What you guys are going to do now is you are going to find, practice this with the half sheet that your substitute gave you. It's the green half sheet. You'll glue that into your notebook right here, and you'll finish it. When you're done with that, or if you finish it in class, then you can move on to tonight's homework. Tonight's homework is going to be the 9-5 Envision Online.